Hello friends, welcome to the Scholarship Draft Survey Numericals. We'll do again and we do some more numericals so that whatever your doubt is left in the previous question in the previous video, you will clear in this video. So once again, welcome to the Scholarship Draft Survey Calculation Part 2. Now I will here explain once again step by step procedure. What is the formula and how you will approach the question. So first, if in question port and starboard draft is given, then we have to calculate the main draft. Okay, if it is not given in the question, then we directly will go to the move next step. But if it is given port like forward port, forward starboard, mid port, mid starboard, aft port, aft starboard, so then we have to add like forward port, forward starboard, then we add both and divide by 2, we'll get the main draft. But if it is not given in the question, no need to calculate main draft. Okay, then very important, make diagram. Okay, diagram is very important to understand the question, it is also good for the examination point of view, so that examiner know that you are know, and if your diagram is good, you will get good marks. So how you to make diagram, I will teach here. In the draft survey question, you always remember that LBP is length between perpendiculars is 143.16. okay, 143.16. now for example, how you will mark the question, how you will prepare the diagram. So you make one vessel, this is your forward perpendicular, this is your aft perpendicular, okay, and distance between them is 143, this is 143.16. okay. Now for example, I give you draft mark 2 meter forward of forward perpendiculars. Okay, so this is your forward perpendicular and 2 meter forward, so this is your forward draft mark. Okay, this is your midship and 1 meter above of midship, so 1 meter above of midship your mid draft mark, and forward is 4 meter forward of aft perpendicular, so this is your aft perpendicular draft mark and 4 meter forward of the aft perpendicular. So how you will calculate the distance between draft mark? So your LBP is 143.16 plus forward draft mark is 2 meter forward, so plus 2, and your aft draft mark is 4 meter forward of aft perpendicular, so less than 4. So 143.16 plus 2 minus 4, you will get 141.16 is your distance between draft mark, forward and aft draft mark. Now we are moving to the third step. We'll apply the forward draft correction, aft draft correction and mid draft correction. The formula is forward draft correction is trim between draft mark, okay, and into distance between forward perpendicular and forward draft mark, distance divide by distance between forward and aft draft mark. Aft draft correction, trim between draft mark into distance between aft perpendicular and aft draft mark. This is aft perpendicular, this is aft draft mark, okay, and then distance between forward and aft draft mark. Same mid draft mark is mid draft correction, trim between draft mark into distance between mid draft mark and midship, divide by distance between forward and aft draft mark. Once we get all the forward, aft and mid draft correction, we'll move to step number 4, draft at forward perpendiculars. The formula is forward draft mark plus minus forward draft correction, draft at aft perpendicular, aft draft mark plus minus aft draft correction, draft at midship, mid draft mark plus minus mid draft correction. Now how we'll decide that this is plus or minus? Okay, so for example, if your vessel is trimmed by stern and your forward draft mark is ahead of forward perpendicular, so then it is opposite to your trim, so it will be plus. If it is towards the trim, like if you're trimmed by stern and your forward perpendicular draft mark, your forward draft mark is aft of the forward perpendicular, so in that case you will get negative sign. So it will more clear when we solve the numericals. Today we'll solve 3-4 numericals. Okay, then you will get forward draft updraft, mid draft, okay, at perpendicular. So then you will again calculate the trim between the draft at power perpendicular and draft at up perpendicular. Then step 6, means of means draft. The F is for forward, A for aft, plus 6 midship divided by 8. This is formula. You should always by heart this formula. You will get means of mean draft in meters. Now whatever value you will get, just go to the MB ships particulars and calculate the LCF, longitudinal center of flotation, which is required for the first trim correction. So you will get calculate the means of LCF from the MB ship particulars. Then we'll move to step 7, first trim correction. The formula is first trim correction is trim into LBP divided by 2 minus LCF divided by LPP. This formula you should keep by heart. Okay. Now we move to step number 8, true mean draft. The formula of true mean draft is equal to means of means draft plus minus first trim correction. Now how you will decide this is plus or minus? If your first trim correction answer is positive, then apply positive. If your trim correction is negative, then apply negative. Okay. If LCF is greater, then your answer will come in negative. If LCF is less than this LBP divided by 2, then you will get positive. So you will get true mean draft. Now true mean draft, whatever value you will get, you just calculate the displacement. Okay. You calculate the displacement. The displacement you will get in seawater because you are using MB ship particulars. Now we are going to step 9. We should calculate MCTC1 and MCTC2, the difference between them. So how you will calculate MCTC1? Whatever your mean of mean draft, for example 9.000 is your mean of mean draft. So MCTC1 is 9 minus 0.5 is equal to 8.5 MCTC1. Okay. Plus MCTC2 is 9 plus 0.5. 9.5 is MCTC2. Now MCTC1 and MCTC value you will get in the MB ship particulars. Write down the value. The difference between them is MCTC1 and MCTC2. Now step number 10, second trim correction. Formula is trim square into 50 MCTC1 difference MCTC2, whatever value we'll calculate here. Okay. Divide by LBP. You will get this value in tons. If in question given the list also like midship port side and midship starboard side, then we apply the list correction also, step number 11. So formula is for list correction is 6D1, means like this is a midship draft port side, midship draft starboard side. So difference between them, and then port side TPC, starboard side TPC value. So difference between them, you will get the multiply, you will get the list correction. Now we have to find total trim. The formula of total trim is initial trim. From where we get initial trim? This is our initial trim. Okay. Then second trim correction, list correction, all add, we will get final displacement in seawater. Now if the question is given RDs, some different density, then we have to calculate the equivalent weight. So whatever final displacement you will get into whatever RD you have, divide by 1.025, you will get the equivalent weight. Now sometimes in question it is given constant. So formula of constant is 0.5 plus 0.05 n. This n is very important. Percentage of the dead weight of the year. This n is the number of year. Like your vessel is built 16 years old. So 0.5 plus 0.5 n into 16, and the percentage dead weight of vessel. Hope you understand these formulas. Total we have 11 step. You just by heart write down in the papers 2-3 times. You will by heart all these. Then we will go moving to the next question. Today we'll solve some different time question. previous in part 1 we solved some different. So let's move the question. How we'll approach the question, how we'll solve the question. Okay. MV hint ship arrived port in partially loaded condition. Partially loaded condition. Okay, with the following draft: forward draft 6 meter, aft draft 7 meter, mid draft 6.55. What maximum cargo quantity you will order to load if C has to sail on 9 meter even keel from this port, but is expected to hog by 5 cm on completion of loading? Then draft mark are located 2 meter forward of forward perpendicular, 1 meter aft of perpendicular, and 1 meter abaft of midship. So solution, how we'll approach this question? First we will make, since we have forward aft midship draft, know the port and starboard, so we'll directly move to the second step. We'll draw the diagram. So first we draw. Okay, now this is consider our forward perpendicular, this is our aft perpendicular. So distance between them is 143.16. Okay, now draft mark are located 2 meter forward of forward perpendicular. So 2 meter, so this is our water line. So 2 meter forward. Okay, 2 meter forward is your forward draft mark. So here 143.16 plus 2 meter. Okay, and 1 meter forward or up. So this is your midship. 1 meter forward of 1 meter forward of aft perpendicular. So this is aft perpendicular, and 1 meter abaft, 1 meter forward. This is your aft draft mark. So it is here less 1. So how much? 143, 144, 145 minus 1, 144.16 is the distance between draft mark, forward and aft draft mark. Mid is 1 meter forward of 1 meter abaft of midship. So 1 meter abaft of mid draft mark. So hope you understand this diagram, how to solve. Now we'll move to the question. Now we'll calculate forward draft correction. So trim between the forward draft mark, and this is 6 meter and this is 7 meter in question. So we have 1 meter trim. So right, trim is 1 meter into distance between forward perpendicular and forward draft mark divided by distance between forward and aft draft mark. So 1 into 2 divided by 144.16 is equal to 0.014 meter. Now aft draft correction. Same formula, trim into distance between aft perpendicular and aft draft mark divided by distance between forward and aft draft mark. So 1 into 1 divided by 144.16 is equal to 0.014. Mid draft correction. So mid is also same, trim into distance between midship and mid draft mark divided by trim between forward and aft draft mark. So same 1 into 1 divided by 144.16 is equal to 0.014 meter. Now we'll move to the next step. We calculate the draft at forward perpendicular, draft at aft perpendicular, and draft at mid. So draft at forward perpendicular is forward draft, which is 6 meter, plus minus forward draft correction. So forward is 6 meter. Now how we will decide plus or minus? Now see in the diagram, we have the vessel trim by stern, but we have the forward draft mark is 2 meter forward, so opposite, so it will be plus. So plus 0.014 is equal to 6.014 meter. Draft aft perpendicular, aft draft correction, aft draft plus minus aft draft correction. So 7 plus it is also opposite of the trim. So 0.007 is equal to 7.007 meters. So draft at midship, mid draft mark plus minus mid draft correction. So 6.55. Now it is mid. Where is mid draft? 1 meter above of midship. मिडशिप से 1 मीटर पीछे है और ये अपना वेसल ट्रिम बाय स्टर्न है, तो ये टूवर्ड्स ट्रिम हो गया. सो इन दैट केस इट विल बी निगेटिव. ओके, minus 0.007 is equal to 6.543 meters. Now we'll move to the next step. Means draft. Forward plus aft plus 6 midship divided by 8. So 6.014 plus 7.007 plus 6.543 divided by 8 will get the 6.535 meter. This is means of mean draft. Okay, means of main draft we get. Now this, for this value we'll calculate the LCF. LCF from the MV hindship particulars we will get 72.061 meters. Okay, use MV hindship particulars and you will get. Now we'll apply this LCF in the first stream correction. So first stream correction is equal to formula is trim into 50 trim का square into 50 divide in trim into LBP divided by 2 minus LCF divided by LBP. This first stream correction formula. Now apply 0.993 into 143.16 divided by 2 minus 72.061 divided by 143.16. Since LCF is more than this value, we get the answer in negative. Now we'll calculate the true mean draft. True mean draft is equal to mean of means draft plus minus first stream correction. So how we'll decide first plus minus? Since this value is first stream correction is negative, we will use negative. Okay, mean of mean draft 6.535 minus 0.003 is equal to 6.532 meter. Okay, now we'll calculate these values. Displacement in seawater. So we'll calculate the displacement is 10957.2 metric tons. These two. Now MCTC 1, MCTC 2. So we have mean of mean draft 6.535 minus 0.5. So 6.035 plus 6.535 plus 0.5, so 7.035. Okay, so we'll get the value of MCTC1 and MCTC2 from the ambient heat particulars 174.3, 184.3, and we'll get difference between them is 10. Okay, now we'll apply in the second trim correction this value. So second trim correction is equal to 50 into trim chi-square into MCTC1 MCTC2 divided by LBP. So we'll get the value 3.444 ton. So in the question we don't have the list correction, no need to calculate the list. So total displacement is 10957.3 plus 3.444 is equal to 10960.74 ton. Okay, this is first part of the question. Now we'll move to the second part of the question, sailing. In the question we have the sailing draft. Okay, what is given in the question? Sailing draft. Let's see. You order to load. Sea has to sail on 9 meter even keel. 9 meter even keel. This port, but is expected to hog by 5 cm. So what is hog? That means this is hog. We have less cargo in center. Okay. 9 meter even keel is sailing. Okay, this is given in the question. So we'll calculate. Sailing is even keel, since it is even keel, 9 meter, which forward and aft draft, and we have less cargo in center. So how much less cargo? 0.005. Okay, so mid draft is 8.995. Now we put this value in mean of means draft. Forward plus aft plus 6 midship divided by 8. So 9 plus 9 plus 6, 8.9. Nine five. 8.95. So we get the value 8.96. 8.96 we get the displacement in sea water is 18961.1 tons, and we have the initial, this one 10960, 109 60.74 ton. This is departure sailing draft, this is arrival. So difference between them is 8000.36 ton. This is our answer. So hope you understand this this question. If you have any doubt, write me in comment box, and you will watch also my part 3. We'll move to the next question. In every part we have solved in different type of question. So if you watch my all 9 videos, you can solve 100% any numerical in the examination halls. So thank you for watching this video. Hope you understand this type of draft survey. See you on the next video with the different question, and best of luck for exam. Thank you.